Today I'm going to be teaching you 4 rules of balancing redox reaction. Simple redox reaction. Then in my next video, I'll be teaching you how to balance complex redox reaction. So today, now if you look at this, we have redox reaction. We have a little or simple redox ionic equation on the board. I'll start by recalling your memory on what oxidizing agent and reducing agent is in terms of electron transfer. Now, in terms of electron transfer, oxidizing agent is a substance that accepts electrons, while reducing agent is a substance that donates electrons. Now, first, before you balance any redox reaction, you must first and foremost know the species that is reducing and or the species that is oxidizing. When a species reduces, it means that it has gained electrons. When it oxidizes, it means that it has lost electrons. So I'm going to be giving you 4 rules that you can follow while balancing any form of redox reaction. Rule number 1, assign oxidation number to the species to balance the atom. That's what I'm going to do now. Assign oxidation number to the species to balance the atom. But before I apply this rule, and I told earlier before now, you must understand which of the species that is reducing. Now, from ion 2 to ion 3, if you look at this, ion 2 have oxidized from ion 2 to 3. So from this point to this point, from here to here, oxidation have taken place. So oxidation have taken place at this point. While if you look at chlorine, from this point to this point, reduction has taken place. Reduction has taken place here. Why this is a reducing agent? Because it donates electron. This is an oxidizing agent because it accepts the electrons. So from rule number 1, assign oxidation number to the species to balance the atom. So if you look at it, this is +2. This is the oxidation number of all elements in a free or combined state is 0. So this is 0, this is +3, and this is -1. Rule number 2, separate the species into half cell oxidation and half cell reduction. So first, having known that from here to here is oxidation. Half cell oxidation, we have that ion 2 ion oxidizes to ion 3 ion. Now if you look at this, this is what we call half cell oxidation. Half cell oxidation. Now rule number 3, balance the atom so as to conform to the law of conservation of mass. If you look at this ion 2, this is +2 and this is +3. So the reactant does not balance the product. So to balance this, we have to ensure that the reactant balance the product. So we can achieve this by assigning appropriate electrons so as to account the number of electron gains or lose. Rule number 3, balance the species so as to conform to the law of conservation of mass. So this is half cell oxidation. So from here to here give us half cell reduction. So we have chlorine now reduces to chloride ion. Rule number 3, remember, balance the atom so as to conform to the law of conservation of mass. This is chlorine molecule, this is 2, and this is chloride, this 1. So it's not balanced. So to balance this, we add 2 here, so it's balanced. I can call this half cell reduction. Half cell reduction. So now, rule number 4, assign appropriate electrons to the species so as to account to the number of electron gains or lose. So I'm going to fall back to this. This will give us ion 2 ion to ion. Now which will now take us to ion 3 ion. So ion have lost 1 electron. So at this point, this gives us 1 electron. So let's check if this is balanced. This is +2. So 3 minus 1 give us +2. So these are balanced. This has become the reactant. This has become the reactant. This has become the product. So you haven't balancing this. Let's move to half cell reduction. So on taking chlorine, now look at very well. On taking chlorine, we have chlorine molecule. So at this point, we are going to have 2 moles of chloride ion. So this is 0 and this is -2. So the reactant doesn't balance the product. What are we going to do? We add 2 electrons here. So if you look at this, 0 minus 2 is -2. Then this one has been able to balance. On looking at this equation, we have been able to balance the atoms. How then do we balance the radicals or the ions? So from here, this +2, these 2 electrons at the reactant side. So looking at the product, we have only 1 electron. So we have to ensure that the reactant balance the product. How do we achieve this? We are going to multiply this equation through. We are going to multiply the whole of this equation by 2. So that we'll be able to ensure that the electron at the reactant part balances the electron at the product side. So for that reason, we are going to, when multiplying this by 2, we are going to have we are going to have that 2 moles of iron 2 ion. This gives us 2 moles of iron 3 ion, then plus 2 electrons. So have you seen it? So we have 2 electrons at the product side. So bringing this one down, we have chlorine molecule plus 2 moles of electron at the reactant side. This gives us chloride ion. So this will cancel out this because the reactant will balance the product. So we are going to combine the two equations together. The whole of this, take note that the whole of this give us the reactant, while the whole of this give us the product. So in conclusion, on balancing this, we now add everything. 2 moles of iron 2 ion, 2 moles of iron 2 ion plus chlorine molecule. This will now give us 2 moles of iron 3 ion plus the reactant side of the product 2 moles of chloride ion. Now, how do you check that the reaction is balanced, that the redox reaction is balanced? By checking the charges. First, don't forget that the number of moles play an important role during redox reaction. So 2 times plus 2 will give us plus 4. Now, this is 0 plus 0. Coming down to this, 2 times 3 is plus 6. So 2 times 1 will give us minus 2. So plus 4 plus 0 will give us plus 4. Now, while plus 6 minus 2 will give us plus 4. So the reactant will balance the product. So this reaction is balanced. So if you have not yet subscribed, just hit on the notification button and the subscription button to stay notified and updated on complex redox reaction. Thank you.